with some 500 planets revealed by ground telescopes. Now the ultimate planet finder, the Kepler Space Telescope, has released a tsunami of data. Among over 1,000 new planet prospects are 200 multi-planet solar systems and 58 worlds in life-friendly orbits. They're all within a narrow window on the sky the size of your hand. That's why this may be the tip of the iceberg in a galaxy that's literally crawling with planets. Scientists are now beginning to envision what these worlds are like, with atmospheres, oceans, geological history. In the process, they are redefining what a planet might need to spawn life. On a clear night, far from city lights, you can see around 2,000 stars with your eyes. That's a tiny fraction of all there are in the galaxy at large. And yet, even with the largest telescopes, most stars appear only as points of light, bright dots that offer few clues to one of our most searching questions. Are there other worlds like ours? Or are we bound to a lonely oasis, Earth, amid a barren universe? So far, in this age of planet hunting, we've yet to find anything like our solar system. Instead, astronomers have glimpsed a diverse planetary zoo, with giant planets in wide orbits around their parent stars, or molten rocky worlds emblazoned with oceans of lava. These finds have added new complexity to theories of how solar systems emerge in the birth of a star. As dust and gas swirl into the newborn star, they form a protoplanetary disk. Within this frisbee-like structure, gravity sculpts planetary bodies that grow in size, sweeping up smaller bodies that form around them. Current theory holds that giant planets forming on the periphery commonly migrate into the inner solar system. This confirms the observation of so-called hot Jupiters orbiting perilously close to their parent stars. But these giants may clear out smaller rocky planets that form close to the star, creating a planetary desert just where you'd hope to find life. Does that make the search for another Earth a wild goose chase? To find out, a group of planet hunters using the Keck telescope in Hawaii examined a sample of 166 sun-like stars within 80 light-years of Earth. Over a 5-year period, they looked for tiny wobbles in the star's light that might betray the gravitational tug of planets. Their conclusion? Only 1 or 2 stars in 100 have a Jupiter-sized planet. 6 have a planet the size of Neptune. To their surprise, 12 have large rocky worlds called super-Earths. This means that as many as a quarter of all sun-like stars should have planets roughly the size of Earth. Now enter the Kepler Space Telescope, launched in March 2009 on a mission to find Earth-like planets. Astronomers aimed its camera into the Milky Way's Orion arm, at a region covering just 0.4% of the sky. Kepler's sensitive detectors are designed to pick up slight dips in a star's brightness, the possible signature of a planet passing in front. Over a 4-month period in 2009, it observed the light of over 150,000 stars within 3,000 light-years of Earth. The data showed that at least in one case, the planetary desert is not so barren. The star Kepler-11 is a yellow dwarf similar to our Sun. It has at least 5 planets close enough to be inside the orbit of our Mercury, with a 6th inside the orbit of Venus. There may well be additional planets further out. That won't be known until 2012, when data from longer orbits is complete. Overall, Kepler turned up 58 planets in the so-called habitable zone. Most are large gas planets. But who's to say that some of them don't have moons with liquid water? Think Pandora. With a growing planetary database, astronomers are beginning to redefine what it takes to spawn life as we know it. Ideally, astronomers will one day stumble upon a world about the size of Earth, with oceans, an atmosphere, a moon to stabilize its orbit, a robust magnetic field to shelter it from solar winds, and creatures beaming television shows into space that reveal their presence.
It's a Volkswagen.
The Blas is kind of like the blues. Only
right down to the germs and bacteria that can cause blemishes.
Until then, the most fertile ground for finding life turns out to be a long overlooked class of stars. M stars, or red dwarfs, range from 1/2 to 1/20th the mass of our Sun, and make up 76% of all the stars in our galaxy. The most famous is in the southern constellation of Libra, just 20 light-years away, called Gliese 581. A team of French and Swiss astronomers had been studying its light from a telescope in the mountains of Chile. They noticed a slight jitter, the gravitational tugging of planets. From this so-called radial velocity, they deduced the presence of Gliese 581b, a planet with 16 times the mass of Earth. At a distance of only 6 million kilometers, it's bound to be very hot. Then came planet C, with an orbit of 11 million kilometers, still too hot. Then there's D, at about 33 million kilometers from its Sun. At the outer edge of the star's habitable zone, it receives only 30% of the light that Earth gets from our Sun. Compare it to Mars, where surface temperatures average around -59 degrees Celsius. Astronomers suspect that planet D is an icy world that migrated in from the outer solar system. It's too extreme to be of interest to SETI, the search for extraterrestrial intelligence, but not to a group called Active SETI. Hoping to hasten contact, the social networking site Bibo, in collaboration with a Russian radio astronomer, used a dish in Ukraine to beam 500 text messages to Gliese 581. Another group used the Deep Space Communication Complex at Tidbinbilla, Australia, to beam 25,000 messages. It's not interstellar spam. Think big, said the messages. We come in peace. And dare to dream. It'll take 20 years to get there, and 20 more to find out if the aliens hit the like button. Or if they need help. Red dwarfs are known as flare stars for the violent eruptions that take place on their surfaces. In 1985, the red dwarf AD Leo erupted with 1,000 times more power than the worst solar eruptions. To find out what that would do to a planet in a close orbit, scientists simulated the blast. They found that ultraviolet radiation from the star would split oxygen molecules in the planet's atmosphere, forming ozone. That could be enough to shield it from harm. Studies like this are prompting scientists to redefine just what they mean by habitable zone. It's the old Goldilocks story. Some bears go for a walk to let their porridge cool. Then a girl comes along. 1 is too hot. 2 is too cold. 3 is just right. When the bears finally return, Goldilocks hops out the window and runs away. Is that a metaphor for contact? We now know it's not just our distance from the sun that makes Earth habitable. Venus is about 41 million kilometers closer to the sun, but because of its thick cloud cover, 30% less solar energy reaches its surface. And yet, surface temperatures spike at 495 degrees Celsius. The reason is that the planet's thick, dense atmosphere is composed of 90% carbon dioxide, a greenhouse gas that traps heat. There's something else at work on our planet. When sunlight bounces off the Earth, water vapor and cloud droplets absorb some of the energy in the infrared portion of the spectrum, transferring it to the rest of the atmosphere. You can see it in this satellite image showing outgoing heat. The most heat escapes from the tropics, where the surface is warmer and there are fewer clouds. And yet, a recent NASA study predicted that if water vapor were the only greenhouse gas, temperatures would fall, sending Earth into an icebound state. Something is needed to act as a thermostat, a control knob, to keep the climate steady. Though it's only 0.038% of the atmosphere, carbon dioxide absorbs enough energy to prop up global temperatures and allow water to remain in the atmosphere. But the Earth did not come gift-wrapped with this balance of CO2. In its early days, the Earth would have released enormous amounts of heat from its core. That drove the eruption of volcanoes and the release of huge volumes of CO2 and other chemicals. In time, some CO2 was removed by chemical reactions between silicate rocks and water, a process called weathering, and washed into the sea. Another crucial factor came into play. Down at the margins of hydrothermal vents, organic molecules gave rise to primitive life forms known as prokaryotes. Other primitive forms evolved with the ability to take in carbon dioxide and emit oxygen in the process of photosynthesis. The ability to cycle carbon in and out of the atmosphere is perhaps the highest bar that an alien planet must reach to be called Earth-like. So far, the closest we've come to that is a planet called Gliese 581g. Though its presence is in dispute, the initial read says it's 3 to 4 times the mass of Earth and located squarely in its star's habitable zone based on temperature. Has nature crafted a life-bearing gem in this distant solar system? Because Gliese 581 is so dim, its habitable zone is well inside the orbit of our Mercury. If there is a planet there, the star's gravity is bound to lock it in place. This means that planet G does not rotate. One side always faces the sun. In our universe, the rate something spins, or doesn't spin, is often imprinted at birth. Our Milky Way, for example, arose in the early days of our universe, when gravity drew countless small galaxies together. The galaxy's spin was determined by the direction and the masses of all the stars and gas that crashed into it. At the center of the galaxy is a supermassive black hole that rotates once every 17 minutes, based on the timing of flares on its event horizon. The spin record for a neutron star is 1,122 times per second, based on the timing of radio emissions. It's like a skater twirling on the ice. As she draws her arms in, she spins faster. Most planets in our solar system spin in a counterclockwise manner if you're looking down on their north poles. The exceptions are Uranus, with a reverse spin every 17 hours, and Venus, once every 243 Earth days. One way to imagine a locked planet is to take away Earth's rotation. The planet weighs 6 billion trillion tons and spins at just over 1,000 miles per hour at the equator. To stop it would take no less than a planetary collision of the kind that probably knocked Uranus and Venus off kilter. When the dust settled, you'd find a whole new world. If you're on the side facing the sun, its position in the sky never changes. Without the day-night cycle, Earth would lose the unevenness of solar heating that helps drive oceanic and atmospheric circulation. The traditional thinking was that any water on a locked planet would fall out as snow on the dark side and be trapped forever. That thinking changed in the late 1990s when NASA scientists simulated the atmosphere of a locked planet. They found that global wind patterns could develop and transport heat to the dark side. Scientists at the California Institute of Technology sought to test this finding by turning off Earth's rotation in a supercomputer program normally used to predict our climate. The team placed the subsolar point, the region facing the sun, just off the coast of South America. This side view shows the new setup. Evaporation on the sunny side sends air rising up in storms and pushing over the poles to the dark side. As a result of this poleward flow, Alaska would experience summer all year round. Land masses on the dark side, including Europe, Asia, and Africa, would go cold. Remarkably, over the 5 decades of the simulation, the oceans retain enough heat to stay clear of ice. On the light side, large parts of the Western Hemisphere dry out, turning to desert. But if you pitch your tent at the subsolar point, you'd find a hot and rainy climate that resembles this place, the island of Kauai in Hawaii. Its highest point is Mount Waialeale. That's Hawaiian for rippling or overflowing water. Known as the rainiest place on Earth, the summit averages 11 meters of rain per year. How would a place like this adapt to sunlight all the time? Plants depend on light to drive photosynthesis, a process that combines CO2 with water to produce sugars needed for growth. They use the day-night cycle to maximize this process to tune their growth rates and take in more carbon dioxide. But in polar regions, some plants are known to thrive in periods of extended sunlight in summer. So if you take away the night, the chances are that life could adapt. But its ability to do so draws upon hundreds of millions of years of evolution in a diverse global biosphere, dependable day-night cycles, and moderate temperatures. The question is whether complex plant and animal life could evolve in the first place on a locked planet. Gliese 581g is already a marginal candidate for life. With its dark and light sides averaged together, surface temperatures are between -12 and -31 degrees Celsius. A team from the University of Chicago sought to investigate its life-bearing chances, assuming abundant water and carbon dioxide. Here's the most promising scenario, called Eyeball Earth. Open ocean at the subsolar point is surrounded by ice. The key is to keep the ice at bay because it can stifle the exchange of heat between water and air. What could tip the balance is the presence of land. A high amount of weathering at the subsolar point could draw too much CO2 from the atmosphere and turn the planet into an ice ball. An explorer from a distant Earth would no doubt head for the transition zone between ice and open water. If there's land there, life might have a chance to thrive in open coastal habitats and perhaps move from sea to land. Gliese 581g and other locked planets are surely nothing like Earth, and yet time is on their side. Our sun was born 5 billion years ago, and it will start to fade in a few billion more. On the other hand, red dwarf stars can burn steadily for tens, even hundreds of billions of years. So with a bit of luck, Planet G may have its day in the sun if it can spawn primitive life and somehow shelter its evolution into more complex forms. Will we ever find worlds in advanced stages of development? With the discovery that our galaxy is likely filled with planets, we are sure to intensify our search. One day, we may well record a telling chemical signature or even receive some kind of text message. For some on this planet, the news will no doubt pass overhead in the headlong rush of technology, crisis, war, consuming, and escape. For others, that day will be filled with humility and wonder in the knowledge that our world is not alone.